Okay, so in problem 2, after you read over it, you need to start by defining your variables. So let's write down define variables. You're going to have to write kind of small to make sure that you have room for everything. So to define the variables, if you have trouble seeing, you can move up front. We have 2 different types of bicycles. So X will be the first one. What was the first bike? What's it called? Thank you. So X is the number of traveler bikes. Number of traveler bikes. And so Y will be the number of what? Thank you. Okay, so write down what X and Y represent. After we write down the variables, we need to write the constraints. Constraints are like limits. Constraints. Alright, so there are 2 things that are limiting us. One of them is the frames, and what's the other thing that's limiting us? Frames. Because I only have a certain number of frames, and I also only have a certain number of what? Time. Very good. So I'm going to have a constraint for frames and a constraint for times. And the constraints are going to look like inequalities. Alright, so we already said that each bike takes only 1 frame. So 1 frame for each traveler bike, which is X, and 1 frame for each tourister bike, which is Y, and I have 300 frames. Can I make more than 300 bikes? No, because I only have 300 frames. Could I make less? I could make less if I wanted to. So it could be less than or equal to 300 frames. 1 frame for each traveler, 1 frame for each tourister, which is going to be less than or equal to 300 frames altogether. The times is going to be slightly more complicated because it's not the same. It tells you it takes how long to make a traveler bike. How many hours to make a traveler bike? 1 hour. Very good. So 1 hour for the traveler, but how many hours for the tourister? 3. Alright, and I could use less than or equal to how many hours altogether? 360. Okay, so those constraints came from the words. Last class we also used some other constraints because you couldn't have negative items. Like in this one we can't have any negative bikes. So the number of traveler bikes has to be greater than or equal to, anybody remember? 0, because you can't have negative bikes. And also the number of tourister bikes has to be greater than or equal to 0. So those are the constraints. We are going to graph our constraints, and what we're going to find is we'll have an area where all of the graphs overlap, and then we're going to find the corners of that area. So I want you to open Desmos.com, and you're going to graph 4 different inequalities. 1, 2, 3, 4. Okay? So go ahead and graph those. Okay, so once you have it graphed, you're going to click on the corners. There's 1. There's 1. There's 1. And there's 1. And then you're going to write these corner points down on your paper. These are called the vertices. So I'm going to list the vertices. So I have 0, 0, 0, 120, 270, 30, and 300, 0. Okay, so write those on your paper. They're written on my paper, so when I switch over, you'll see them. Okay, so those are our vertices. Make sure you have all your vertices written down, because we're going to now figure out what our objective function is. Remember, an objective is like a goal. So every problem has a goal. For this one, it says we want to maximize revenue. What's revenue? Money, that's right. Revenue is money. So we want to maximize our money here. So the revenue, it comes from, okay, so the revenue comes from $200 for each traveler bike plus $600 for each tourister bike. So what we're going to do now is we're going to substitute each of the vertices into our objective function. This is called our objective function. So we're going to put each of these into our objective function to figure out which one gives us the most revenue. So I'm going to do the first one. If I put 0, 0 in, what's 200 times 0? 0. And what's 600 times 0? 0. So my revenue, if I make 0 travelers and 0 touristers, my revenue is 0. That's not a surprise. So my revenue for the first point is 0. Alright, so next thing you guys need to do is you're going to substitute 0 for the x, 120 for the y, and you're going to find out how much revenue you get if you make 0 travelers and 120 touristers. So that's literally like a calculator problem. I'm going to switch it back to my calculator to do that. So it said 200x, so instead of x I'm going to put in 0 plus 600y. So instead of y, I'm going to put in 120. Oops, that was just 12. Alright, did anybody else get 72,000? So I took my revenue function, 200x plus 600y. I put 0 for the x, I put 120 for the y, and I got 72,000. So I'm going to put that on my paper. So this point gives me 72,000. So what we're going to do now is if you're in the front of the classroom, I want you to plug in this point, 270, 30. If you're in the back of the classroom, I want you to plug in the point 300, 0. I'm going to give you a minute to do that. Alright, so some of you guys found something interesting happen. For this point, what was the revenue that you got? It was 72,000 again for this point. And then the last point, what was the revenue? 60,000. Okay, so a couple of you finished already and you noticed that this is the maximum revenue, 72,000. So you need to make a statement now. You want to write your statement. Maximum revenue is $72,000, and that could be from, it could be from 0 travelers and 120 touristers, or it could be from 270 travelers and 30 touristers. Okay, so make sure you have your statement. We should probably box it up somehow. I know we're low on space, but find a way to box it up so that we can find your answer easily. And you can look ahead to problem 3. We're going to do problem